Hello students, in this video we'll see an example of using the chain rule. Let's suppose that z is a function of x and y, and x is equal to u plus v, and y is equal to u minus v. So x and y depend on u and v. Let's find partial f partial x in terms of partial f partial u and partial f partial v. Well, we know how we would do this. We would just use the chain rule. So the chain rule states that partial f partial x, which is what we're trying to find, is partial f partial u partial x plus partial f partial v partial x. And let's draw out our tree configuration. We have two different trees we can look at. We have z, which depends on x and y, and x and y depend on u and v. But we can equally well think of this as z depends on u and v depend on x and y. So either of these tree structures work. The tree structure that we're using here is this tree structure. So we need two quantities over here. We need du dx and dv dx. And that would be useful. We could find those easily if we had expressions for u and v. But as it stands, we don't have one equation for u. We have two. So what we're going to do is we're going to do the derivative of u with respect to x. So what we'll do is we'll take this system over here, take star, the system, and do the derivative with respect to x. And so what we'll get is the following. If we do the derivative of x with respect to x, we'll get a 1. If we do the derivative of u with respect to x, we'll get to du dx, because u depends on x. And then plus the derivative of v with respect to x, because v also depends on x. Likewise, we'll do the derivative of y with respect to x. This is really a derivative with respect to x, treating y as a constant, because x and y are the independent variables here. So the derivative of y with respect to x is 0, and that will be du dx minus dv dx. If we add these equations together, we get twice du dx is equal to 1 by adding those equations together. So du dx is equal to 1/2. Now, if I want to solve for dv, I know that du dx plus dv dx is equal to 1, so dv dx must also be equal to 1/2. So what we have from this is now we can plug these values in. So what this tells us is the chain rule can now be updated. It says that df dx is 1/2 df du plus 1/2 df dv. Now this is very useful because what this tells us is, as a differential operator, this tells us that d by dx is really 1/2 d by du plus 1/2 d by dv. So if you want to do an x derivative, that's the same thing as doing 1/2 of a v derivative plus 1/2 of a u derivative. So for example, if we wish to find partial squared f partial x squared, what we would have is we'd have 1/2 of a u derivative plus 1/2 of a v derivative. That's my dx derivative of 1/2 df du plus 1/2 df dv. And so now what we'll have is we have to essentially FOIL this out. And so what we'll have over here is we're going to have everything's going to have a 1/4. So let's pull that 1/4 outside of everything. And then I'll have a partial squared f partial u squared. I'll have 2 partial squared f partial u partial v. And then I'll have a partial squared f partial v squared, which says if you want to do a second partial derivative, you have to do 1/4 of the quantity 2 u derivatives plus 2 times a u and a v derivative plus 2v derivatives. And you can sort of see for this particular special type of coordinate change, this resembles a binomial structure. And so the second derivative has this implicit binomial structure in it for this particular choice of coordinate change. So we've seen that if we want to use the chain rule, the choice of tree matters greatly. And once you choose the choice of tree, be very careful with your partial derivatives because some of them are actually constrained partial derivatives. Thank you very much.